Hi, welcome to Shader Hour with Zed. I'm going to pretend like there are people in my chat. There might be one person in there right now. I don't expect many of you tonight, but I appreciate anyone who stops in just to take a peek or sticks around for a while. I'm going to be working on some shaders. You can see this nice shader I have here. Maybe you saw my previous gift of it on Twitter or something. It was fun to make. It was a challenge. I've been working with shaders for a while now, and I recently got a Pixel Spirit deck, and this is an amazing product. I wish I knew more about tarot cards to fully utilize the magic in here, but for now I will stick to just the shader magic, which is one of my favorites. So every card has an image. This one is the Void. The Void is the simplest, of course. I left them in order for now. I didn't shuffle anything up just to get myself started. And in the back of the cards, so I'll show you the Void. Here's up close, just in case you couldn't tell. It's pure black. There's some shader stuff on there. I don't think you're going to be able to read that. Apologies for that. I'll show you in the text. I will show you the Void. Here, let's scroll down a little bit. And so, the Void. You want to see the Void? We did it. We did the Void. Challenge completed. This was wonderful. I mean, I'm gonna stop streaming now. I think that was nice. Well, that's not totally true. I'm just being silly now. But here, let's rewind this. Go back to color, and then let's just do a second one and do color is equal to mistype there. Okay, yeah. My instinct here also is to Control S, but I'm using a online editor for this. This editor is really cool. It is the editor.thebookofshaders.com. It's linked in the description. The Book of Shaders is a fantastic resource for learning how shaders work and the beginning of all of that. I also the same author as Pixel Spirit, Mr. It's right up here, Mr. Patricio Gonzalez Vivo. Very big inspiration for me in my shader journey. Another one that's up here that you might notice is Inigo Quiles. Just phenomenal shaders and graphic work. I am going to steal a lot. Actually, some of the functions in here. These are from Inigo. I stole those, but only because I couldn't remember them. And that will be the theme of what's going on tonight. I'm going to draw a card, and hopefully it's not like insanely complex, or hopefully I mean, maybe it is, and that's a challenge. That is fine. But I'm just gonna close this little door here. And then I'll draw a card, and I'll try to complete it. I got about an hour or so. It took me about 40 minutes to do the Oak, which was the last one. This took me about 40 minutes, and that was with referencing as little as possible, except the SDF box functions. Those are the only things I copied. Lots of trial and error. The time lapse is really fun. I really like looking at it. Another cool thing about this, I'm going to full screen again, is this test function. I didn't know until recently that this was a thing, but you can test, which what it'll do is it kind of runs through every line of the code and renders something at that line. I'm not really sure what it decides to render, but it looks cool here, so let's just have a look at that. Those are UV. I changed it, rotated it. Lots of black. Oh, there's our distance field. Okay, I'm moving that distance field around. Okay, more distance field move around. Boom. I mean, it kind of, that ends up looking a lot like the draw 2 circles, then draw the owl meme, because you don't see all the in-between. But hopefully, we'll see a little bit more of that in-between here. I am going to wait a tiny bit before I start. I don't see why though. Maybe I should just start. Yeah, let's just start. How about that? Okay, so I have these cards in kind of like the order they came in the box. And what I did last time was I fanned them out and I picked one kind of in the middle. The oak was kind of in the middle. And I was thinking of doing that again. For some reason I don't want to shuffle them. I know they're all numbered and I could put them back to their original order really easily, but I think the intended purpose of these is like you learn your way from the front to the back. At least that's how I would do it if I was trying to learn. Right now this is more of a challenge, so just kind of jump in the middle. But then I don't know, randomizing. The other thing about not shuffling them up is the back of all the cards has the shader code on it. So they're different and they're not exactly like, theoretically I could see the back of a card and be like, oh yeah, that's the oak, or that's whatever card it happens to be. I will just go ahead and I don't know, maybe I'll just start going through until that's a good idea. I'm just gonna do that. Okay, well let's do the void. Card number 1. The void. Okay. And I'm gonna do this, if it wasn't clear, I'm gonna do this without looking at the code on the back. It is very simplified code on the back, like often omits the boilerplate stuff. Yeah. I see. Okay, so I'm going to erase everything here. Color. GLSL is my favorite shading language so far. I've used HLSL, I've used Unity's, was it CG Lang? I forget what they call it. Used Godot shader a little bit. And yeah, I just GLSL. OpenGL is find the most user-friendly of all the languages, especially if you're starting out. So there we go, we did it. We did the void. I don't think this is worth saving. But I am going to do it. The void. There. I'm going to zoom right in. You can see this for a second. Look at that. Shader code. We're getting started. This is fun. Whew. So, that was the void. Pretty easy, pretty straightforward. The void, just render everything black. I'm not going to go into depth teaching things unless anybody shows up in chat and is asking. That's just what I'm going to do. Okay. Next, card number 2. Kind of nice. Very, very geometrical. I wonder if that's going to focus. Justice. Yeah. All right. See, like, hold on. I don't even want to save this. I'm going to export it just in case. Download file. The void. Let's do it. Okay. So, gonna erase this. Call it justice. Coding, or comments at the top, obviously, with the brackets. Okay, how to do justice. So let me take a look at it. So this is it's really good. I really haven't looked at every card yet. I mean, like, I've looked at them, but I haven't, like, with my analytical brain dived in. And I hope justice justice demonstrates that it's one of the first things you should learn as a shader artist is how to manipulate the coordinates. So let's just, for a second here, ST, by the way, could also be UV if you're more familiar from a game design perspective, UV is pretty common, and you might recognize this color, UV. I love UVs, but shader code, we often call this ST. I forget what the ST stands for. It's like I don't remember. It's pretty common to see ST. I've also gotten the habit of using P. This becomes more useful when you're doing some distance fields, but P kind of represents point, and what it's saying is it's this specific point in the resolution on the UV. So like this one right here where my mouse is, or this one up here, color it based off of its position at that point, which is the vector 2. So P is useful. I'm gonna stick with P, I think, for this. It's just generating coordinates, making sure that's right. You can tell because you're going from your 0 to 1 on the red channel, 0 to 1 on the green channel, 0 to 1 on both is yellow. But now we can manipulate this. Let's do P minus equals 0.5. Not necessarily totally obvious, but that is our centering function. So now our 0, 0 is dead center. Kind of our 1, 1's now not on the screen because we haven't scaled it. I mean, I could scale it to be 1, negative 1. Let's try that. 1 times equals 2. Yeah, there we go. I probably didn't need to do that, but now you know center's 0 and the extremity is actually 1. If you shrink it any more than this, I think that's 5, so I think our 1's like here. You can see the gradient, and then it's just solid. It'll still gradient left and right between the colors, which creates this kind of nice pattern, but I'm not going to do that. What was I doing? Oh, I didn't have to move P. I just got carried away. So let's see, what do we do? So we have P. So we justice. Look at it again. I always need to. We have our x0 going over this way to x1, and at exactly 0.5, it changes from black to white. And this is most easily done, I think, with what's known as a step function. So I'll do a float value. D is often used. You could do value. I don't know what to do. I'm just going to do D. And we do step function p.x because I only want the x coordinate, and let's do 0.2 just because I always forget what. Let's see, I'll put D in there and put color here. Oh, almost had it. Okay, so we are backwards. I think I just screwed up the order. Yeah, I just screwed up the order. Okay, so the first function here. Ooh. Yeah. This is why I like the online editor. We got cool tools like this. This is really cool. But if I want to do exactly 0.5, I can do that. And px. So step will take the second argument, which is the value, whatever the input is, and make everything in that value that is less than the target black and more than the target white. I think equal then might be white as well. It's hard to know for sure. And not that it really matters when you're dealing with this. I mean, it might matter in some cases, and at that point I would look it up. But does this look like justice? Did we do it justice? This is strange to me. Yeah, I think we did justice. I mean, and I could check on the back. So they sign the color. They sign a black color. They set up the resolution, and they just add the step, which is interesting. I don't know why you wouldn't just assign it, but that's fine. But yeah, do a 0.5 step on the x-axis. Easy. That's shader 101. You got to be able to. You're manipulating space. So cool stuff now. Let's do D0. I want to do some cool stuff. Yeah, now it's red. See, because I put the zoom in a little bit. I put the D value just inside the red channel, and obviously I could do the same. Create a nice magenta pink, mistake magenta, as my old professor used to say. And yeah, but I mean, here's an example of why GLSL I find is really useful. Is because you can construct a vector 3 with a single value, and it just interprets that as you just want the same value and everything. And I've HLSL being a little bit more verbose, you might say, you'd have to do this. Which still works in GLSL. So copying code from HLSL coming over to GLSL is sometimes a little bit easier, but this is just extra steps, especially when I'm doing stuff like this and I want to go fast. So next card. I can see it before you can. It's the nature of the off-screen cards, but it is called Strength. And remember, these are all technically tarot cards, I think. So you do like tarot readings with these like really cool shader design cards. I'm gonna give you a taste here. I'm gonna give you a taste of one of the cooler ones. Let's something I really like. Oh yeah. Oh, this one's cool. Look at that. The Empress. So this one uses a function. I was looking into it a little bit because I like it. Uses a function for generating polygons, which again, like the box I had at the beginning of this, would be not impossible for me to do on my own, but it's one of those like functions that honestly you should just memorize and use it. Like you don't need to understand how the inner workings work. Like, how did I generate this function to know that it works? And anyone who tells you you'd have to do that is kind of a hypocrite, because every piece of technology we use is built up on thousands of functions you listening to this right now, you don't understand. Sometimes I wonder if anyone does. It's one of those things, but okay, let's continue on down the path. The Empress is going to be cool, but I'm not going to do that right now. Let's get back to Strength. And anyone recognize that shape? God, I say anyone like there's people watching, but there's literally, I don't know, maybe not no one. Like, it says there's one viewer. Is there one person here? I hope so. That'd be kind of cool. It shows one. Maybe it's just a pal of mine who put it on and then forgot. We'll see. Okay, yeah. Oh yeah, I want to export all these. How does it... Does it pull that from title? That would be cool. Okay. The title. Strength. Alright. I like to start from 0 because they kind of build on each other. And you kind of saw where we came from here. So Strength. We have this wave, and whenever we're dealing with waves, we're often dealing with sine functions. So, we want this to wave kind of... We want this line to wave, and we want it to wave relative to going up and down, which is the y-axis. So, one way we can do that is... just create some new variables just for fun. Just call this y. Y is equal to the sine of py. And that didn't change anything because... Oh, okay. Shader errors are the best errors because they just create these insane art pieces. But, okay, that obviously didn't quite do what we want, but the most likely culprit is just so this is fine. Okay, now we have to figure out what is it doing. And easily, you kind of just slap that in there and you go, okay, what are you doing? You're 0 at 0, which is sine waves, right? And then you are going up pretty quick. Oh yeah, we gotta change the frequency. So it is this times this. And let's bump this up to 20. There we go. Okay, got some sine waves. That looks kind of right, maybe. So let's put this back as our value. Oh, okay. Not exactly what we wanted here. I'm going to multiply this by 10. Yeah, I figured I want to divide it by 10. 2. Okay. Okay, so let's take a look at strength again. So it is the point where the step occurs on x is relative to that. Oh, right. Okay, and now I need to normalize the sine wave, which okay, so sine waves go from -1 to +1, which means you have to multiply by 0.5 and add 0.5. And then, this probably still won't work. Oh, hey, almost. We're definitely in the right shape. And let's see here. Oh yeah. Oh, see, this is what the woo. Okay, so we kind of just as a reference point. It's kind of almost all of it. I'd say almost all the way, like so. Yep, and then I will do this. Oh my god, that's almost perfect. Okay, and also, so this one is taller, so that will in turn affect it. But that looks pretty close, and obviously you could just tweak the sine value. So that I'm going to call that one done. I realize I'm holding this up to the camera, and I mean my hand is covering it, but just trust me, please, that I'm not looking. I don't want to look. It's mental practice for me. It's exciting, but let's look now. Now that I've called it done, this one is complete. Zoom up on the code a little bit. Yes, step, and then it is a cos function. Did cosine instead of sine, which is all relative. Basically, it's just the numbers would be different. Multiply by pi. Why would you multiply by pi? Now this one in here, he did pi. So let's do a float called pi to right. That's so cool. Anyway, okay, so that's done. Doesn't really look like it with this particular. Remember what number I had? It looked nice. It was about there. That's about. Okay. A little bit more warped, a little bit squishier because it's different, but that is justice. I'm calling it. I called it already. Download strength. Sorry, strength. Yeah. Okay, next on the list, death. Not a good omen from my third card of the night. Well, we don't count the void because everything comes from the void. But death. This one is, yeah, I mean, it's easy or tricky depending on what way I want to go with it. And I think, like, say, okay, oh, almost saw it. I don't want to look, but let me look over here. Let's look at that. It's got this diagonal line, and there's a way to do diagonal lines that I totally forget how to do. But it has to do with, you're dealing with the x and the y coordinate again, and then using a step to make the black and the white. Yes, what should I erase here for now? Okay, I'm gonna get this back to kind of justice. And let's see. See, so the spacing of this one was tricky to me because it didn't seem to imply. It's not corner to corner. It's not exactly 0 to 1, 0 to 1. It's kind of around this quadrant here and this quadrant here. I assume you can see my mouse. I hope so. Anyway. So, okay, so let's see. Let's take P, our point, and multiply it so that this is just one of those things I have memorized. Okay, and now we can drag this one up again. And basically I'm done. Basically, where am I rotating it from actually? It is weirdly rotating. Okay, so I'm going to actually, I want to look at P. So this often will go back to this. That's our boy. This is the color space. So I'm gonna tweak this dial, and what you might realize is that I'm rotating. So rotating it left, rotating it right, 0 being perfectly in line. And so here's a trick now. If you move P 0.5, we talked about this in the beginning. We have we're moving it on the x-axis by half and on the y-axis by half, and that puts our 0, 0 right in the middle. Now, so I could change my step to be a 0 step and go back to color. And now that's going to rotate around the middle. And boom, I think that's dead. What do you think? Again, square versus rectangle. Give me some allowance there. But we're doing, so this is a matrix transformation. That is this cosine, negative sine, cos. It's just a thing I memorized because it's really useful to have that memorized, which is a rotation matrix, which will take a 2D rotation matrix. Really handy. You input a number. Whee! Alright, let's call it 1. Nice and even. That looks good. I like that. So let's see. How many else? Oh, how did he do it? Okay, no, this is the fun part, because I don't think he would have done a rotation matrix. Death, let's see. This is the interesting part. Well, now what is that? So it's a step function. Okay, let's comment this out. Okay, step at 0.5, and then px. Hold on. Can I dupe line? No, we don't have duplicate line. Okay, just kind of reassign D. I just want to see what exactly is happening here. So, P. I already saved it. Okay. So, and he has. Let me see. So we're adding. Oh, adding them together. So px plus py. Gives me that. Okay, and for reference, he also multiplied this by 0.5, which I don't know why that creates the. Oh. Okay, so this is the code he used, and if that's correct, I think the card is printed in a way that this generated a square image, but the rectangle of the card cut out that square image, which works fine for most of the ones, like the oak and stuff, where because everything is center focused. Let me just double check. So we have color, then we have coordinate, and he adds the color. I just make it equal. 0.5 st plus s1 times 0.5. Yeah, I mean, I think there's very few cards that would be a problem for, but this tricked me. I actually thought this was harder than it was because of that, and that's interesting. That's just, I guess I would have assumed. You see, I would have written like a shader with a box that was the proper size. Actually, I can show you that. I can inspect this guy, and I can change the height to, let's say, 800. So see, hey, it's a card. But see, it's not just like the card, because his card has those it doesn't go right to the corner. So he's definitely rendering out a square image and then cropping it to a card, which in most cases, again, would be fine, but it does change things a little bit, and it's worth noting. And I just find that interesting. Okay, I'm gonna do something here quick. I'm going to reduce the size of our boy, so I can zoom you in a little bit more with. That was too much. And there's this weird craggly line now. Was that always there? Let's see. No, it's cleaner on 500. So you know what? For no other reason than the aesthetic appeal, it's gonna stay 500 for now. Well, that just messes everything up. Hey, there's death. I like my death better. I think that's part of the appeal to me. Okay, next. Next one. This is good. We're going through them quite quickly. Oh, don't save. Instinct. The wall. Inigo hasn't really done much yet on this stream, just in terms of not using the functions, but still a great inspiration to me in general, so I'm going to leave him there. Also, again, Patricia, these cards are amazing. Like they're so cool to look at. Like, I know you don't get a good glimpse on my webcam, but like it's gold plating. Normally you get gold stuff, I'm not really into it, but just with the black and the white and the gold, and there's like details on every card. Like, these are nice. These are very nice cards. And there's lots for me to go through, so I don't know. Maybe I'll make this shader thing a common event. Something for me to do. Talk to the void for a little while. There it is. Hi, void. Yeah, I'm getting tuckered out. I might do one or two more, depending on how quick they are. Let me just check on the thing. Oh. Okay, back to shaders. So we're doing the wall. I didn't show it to you yet. Here's the wall. Okay. I'm not looking. Can you see it? Pretty straightforward. Couple ways to do this. One way I would do is like what we did with was it Justice? Yeah, what we did with Justice, just a step, black to white, define a value, say this is black, this is white. The wall's pretty center, so you could define everything before 0.4 to be black and everything after to be white, and step only works in that binary sense. And then you could define like the other area, the next area, as like a subtractive area. So it would be everything after 0.6 is white according to the step, but you subtract the second step out of the first step, and I'll show you what I mean. Okay, so let's erase some of this stuff here. D float D, okay, equals to step of px. We know, oh wait, let's do 0.4, that's what I said, right? P dot x. Okay, so that's like the first part of our wall. Now, we need to subtract that, so D minus equals step 0.6 px, p dot x. Boom, there, wall. Wall's easy. I like wall. Death was trickier, but does that look like the wall to you? Yeah, just the thicknesses. I could make this more like programmatic and go like float thick. And call it 0.1. It's not what I did, but I'll do it. And then it's be 5 minus how many C's did I put? 5 minus thickness 0.5 plus thickness. Yeah, it works. And this is like, it's all auto running, so that shows me it's working. We can like, oh, I made a cool laser effect that basically did this once. But if you stretch this out to be really, 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 really long and skinny, then yeah, it looked like a laser, and I added more effects and stuff. But let's do 0.1. Oh, I'm already at 0.05. That looks more like the card. Okay. Just checked it back, see what he did. I'm calling this one done. Yeah, I did a step minus a step. I did it in 2 lines, he did it in 1 line. Oh, and a clamp? Oh wait, hold on. Different technique. Let's check it out. Stroke. Oh, okay, so this is important. So now we're defining a function, and I'm going to copy this because it's going to become useful later. So yeah, oh yeah, I kind of used a thickness parameter. So let's go ahead and try the same. So float, stroke, 3 variables. What do we got here? We got x, we got s, and we got W. Okay. Float x, float s, float. So this would be me just straight up copying it at this point. The problem with this is return does not return a value. Yeah, I kind of did, but there we go. Yeah, the update thing is tricky. Let's see. I don't really want to do this now. This feels like more tedium, and I kind of want to get through some more. I might come back to this later, but this just looks like making this kind of effect easier down the road, which is gonna be easy, or is gonna be necessary, and oh my god, I already see why. Hold on. Here we go. Okay, so I'll show you the next one. Did I save the wall? I didn't save the wall, did I? I'm not gonna do stroke right now. This is fine. Export, download, save the wall. Boom. Cool. Okay. Next up, in order. I don't know if this is probably not a canonical tarot card order. I don't know. I literally know almost nothing. So someone teach me about tarot cards, and then I'll I'm trying to be respectful because I don't know anything. But if you teach me, I will do something. Oh yeah, what was I saying? Temperance. This is cool. This one is neat. A few ways that can be done. Temperance. So yeah, it's sort of, I think this is where like stroke comes in handy at this point, because you're going to do 3 strokes. So I might do my own little stroke function here. I should probably do it. Float, stroke, float, what was it? S, float X, float W, return pseudo. Okay. And so, float D. I like D. Take kind of this. I will just do 2 C's. Let's just take that out of there. P. Oh, we don't have P. We do have X, though. We do have X. Oh, S would be the location. Yeah, okay. S. Let's see if this works then. So get rid of this. D equal to stroke at. Okay, so our location in this particular case, 0.5. Our X is P of X. And our thick is 0.05. I forget what I did. Okay, so it is our value minus our thickness. Oh, I returned 0. Yay! It was an easy error. Okay. Yeah, I'm returning 0. So yeah, then so now stroking is easier. Back to the point of the matter, temperance. Okay, so this looks a little bit like a combination of the wall, 3 of the walls, what we just did. So we could do that right now. We can d plus equals another stroke and see what 0. Let's do 0.7 maybe. P of x 0.05. Oh, okay, cool. So that will work as expected. And 0.03. Yay, okay. So now, how do we get them to curve? How to do a wiggly wiggly? Whenever I get the chance, I like to do the linear transformations, because I can already think of a way to kind of do that. That doesn't mess with the stroke at all and just changes the space. So let's try to do that. So P times equals, let me do a mat too. Okay, and so it's not a rotation, but it is along the y-axis. I forget how this works. It's top row, bottom row. So if I do 0, 1, 1, 1, 0. Oh, hey, I rotated it. It's kind of a rotation matrix. It's 1, 0, 1, 0. It's not 1, 0, 1, 0. I feel like that's not. I feel like that's rotated and just, yeah, okay. I feel like that's standard. Did I have the ones in the middle before? Yeah. I'm trying to envision it. I think it's X. And then Y. Yeah, X and then Y. Let's stick with that, because that seems accurate. So this is the identity. Oh yeah, it is. Oh, the identity. It's the diagonal. I just remembered that. Thank you. So the identity matrix is do nothing. And if I take this 1 and I make it longer, this is the X, and means everything should get fatter. Ooh, the fatter and goes that way. All right, because our 0 is not center. Right now, our 0 is not center. Yee-hoo! And what you kind of want is you don't want fatter. You want to move it. Okay, so I could try putting sine of py in here. What is that? See, this is okay. Sine of py. I like this. Why you gotta... This isn't doing anything now. Oh shit. Let's undo. Okay. Why is it going all crazy? Let's multiply by 2. See what happens. Whoa. 20. Whoa. 10. 5. 2. 1. 3. Okay, so it's definitely doing a sine wave like thing. But I've screwed up the matrix, I think. Okay, I'm going to look at linear transformation. I'm going to Wikipedia. Nope. Math World? I mean, you're probably fine. Okay, what am I looking for? linear map? No, what I want is whoa, why is this so hard to find right now? Okay, here we go. Yeah, okay, so it is this one. But I don't think I'm doing that right. I'm just going to try another approach. I was trying to get fancy. Apologies that I was trying to get fancy. So let's just kind of carve that out for now. So how can we make these guys wave? Well, instead of px, we could do... Sure. Not sure. px. Well, instead of 0.5. Oh yeah, it's like, okay. So float y is equal to let's do 0.5 plus the sine of p dot y times 0.1. And I'm hoping PEDMIS carries there. Basically what I want that to do is I want that to fluctuate from 0.4 to 0.5 like this. And let's do y. Okay, yeah, we're not doing the frequency enough. I forget what the frequency was in the last one that worked for us, but that looks good. And then let's do 0.5. Oh, not quite. Not quite 10. Not quite 5. Our thickness is a bit much. Let's do 3, 4. Okay, so I'm just gonna copy this down a little bit, and so in this case I'll do y minus 0.2. Yeah. Y plus 0.2. And that looks to be about right. Yeah, okay. So what do you think? Yeah, okay. Gonna call that one then. And looking at the back, cosine offset adds an offset. Yeah. Offset, which is the cosine of y times pi. What do we multiply? 6? So it's a little bit more. Again, taller card might account for that. I'm not sure. Oh, what was that? That was number 5. Might do 6. Might do one more. I think I can do it quick. Okay. So let's get rid of this, clean it up. Everything there is important. We need stroke. We didn't use pi, but it's there. That's fine. Temperance. That's what it is. Okay. Export, download this. Save. Okay, next one. The branch. It's kind of like death and a wall sort of thing. And 2 ways you could do it. You could try to do the weird math where you add in X branch. Okay, go down. Gonna leave stroke. Stroke's been useful. And alright, let's see what we got here. Okay, stroke. I'm gonna unwiggle it. I'm gonna return this to 0.5. And I just gotta rotate it. And this part's almost too easy. So we take the point p times equals at 2, and here's the memorization. Cos. Oh yeah, hold on. I like t. 0 cos of t and sine of t and negative sine of t. Oh. Wow, I am just... What is going on today? Yeah, why are brackets not the default? I'm a programmer. I don't ever need 9 and 0. Come on, I need left and right brackets. And cos again. And I'll just take it and... Oh yeah. First, I will minus equal 0.5. Here. So I'm changing things up a little bit. So I'm putting my world origin, my 0, 0, in the center of my square with this line, and then now I'm going to rotate it around that origin. And branch is like so. Okay, what do you think? Easy peasy? Okay. Check here. I'm doing minus. This one's a little bit strange. We're not setting up any new functions, but he is doing the x-coordinate minus the y-coordinate normalized to 0 to 1, and then plus 0.5. It's very strange. And then that goes into the stroke equation. I like my way better. Okay, we'll do one last one, because this one's really easy. This one is piece of cake. So actually, before let's just do that. -1. Right. Okay. Perfect. So I will export the branch. And then, okay, the next one. It's kind of a continuation of the branch here. So I'm just going to set that up. The Hanged Man. All right, you ready? It's as easy as it looks. So it is just, well, at least for me, I'm going to duplicate and do it again. Okay, so here, what I'll do is I'll set t now equal to +1. I guess I should do +2. Yeah, okay. And then take the matrix again. And hey, look! It's the other way. I did 2 because I have to undo the 1. And this is in radians, I believe, so it's like a 3.14 pi would be half a turn? No. 1 full turn or something, yeah. And, okay, yeah, and then, so, but instead of that, I just gotta move this, put that there, and then d plus equals stroke, what did I do here, 0, 0, px 0, 0, 4. I don't quite like that. It doesn't look as clean as his. Oh, I think that's just the amount that it's being bent. They're not perpendicular, whereas if you look in there, the cross is definitely perpendicular, and his function guarantees that, whereas mine requires me now to like, oh, what is exactly here? Hold on, let's do 0. So that's 0 is exactly perfect. Oh, jeez. Okay, if 0 is exactly perfect, and I'm only looking at the up and down right now, I know they're both going to move, then how much for exactly how much is exactly diagonal? That's about it. 7.2, which is, we're dealing with pi stuff here, so negative pi divided by 2 over 4. Yeah, negative pi over 4. That's the 0.7 something. Yeah, that makes sense. Okay, so then reset this to equal to positive pi over 4, which will just make it straight, and then I don't know, do pi over 2. Yeah, okay. Let's do plus equals. No. Yeah, now it's perfect. See, that was gonna bug me. I just had to get the math right. So the Hanged Man. Maybe that is my final one for the night. I can see the next one. I'm not gonna do it. I'm not gonna tell you what it is either. That's just too tempting. The Hanged Man is the final one for tonight. For my one concurrent viewer throughout this chat. Thank you. To anyone else who may have popped in for even a moment, thank you. I'm going to do this again, and maybe I'll get to talk to somebody next time. Maybe. That would be nice. For now, I'm going to save the Hanged Man. I'm going to bid you all farewell. Thank you for watching.